Hi, everyone. Thanks for joining us for our chat around cost in the observability space and the challenges associated with it. We'll give just another minute or two for any light joiners to arrive, and then we'll kick it off. Okay, great. So let's go ahead and make a start here. My name's Or. I'm head of product at Groundcover, and we have with us Chezi, who is our CTO and co-founder here at Groundcover. Say hi, Chezi.
Hey guys, what's up?
Great to have you. We're going to be talking about a subject that I know is very interesting for you today. It's the challenge around cloud costs within the observability space, the dilemma between scale and coverage, quality, and ultimately the cost associated with it. And where do you draw that line? So we're going to talk a little bit about ground cover. We're going to show kind of our journey within this space. Then we're going to dig into that deep dive around the cost paradox within the observability space. And we're going to move on from there to a little bit of back and forth between us. And finally, we'll do a demo at the end and a Q&A. If there's anyone in the audience today that wishes to ask questions, of course, you could save it for the Q&A, but also feel free to ask throughout. We'll go ahead and kind of see that within the flow and be able to go and incorporate it into our conversation. So let's have some fun, Chezi. Wonderful. So this is our journey so far. Groundcover was created in August of 2021. Since then, just over 2 years has passed. We've raised over 30 million in total funds. We have close to 2,000 users today, a variety of large name, multi-billion dollar companies that are using us to go and cover their entire stack. And we're just grateful that all of these companies have decided to make us a part of their solution and in a space that's just so critical. In terms of what ground cover actually is, I think most of you have probably seen it within the website or used the product itself. But ultimately, ground cover is a single place where all of your observability pillars could be served, whether it's metrics, traces, or logs. All of this happens in a Kubernetes first approach, but incorporating all of your different data sources as well. We do so using the power of a technology called eBPF that we're going to be talking about shortly, and with a very special architecture that we believe is the solution to this cost paradox. So jumping right into the material, I'm going to start by showing a little bit of market research that was performed by ETR Research, a globally known research organization. And what they basically saw is a fairly difficult situation of the market. They saw that the average company that they asked essentially had more than 5 different tools within their observability stack, essentially creating a disconnect between how their users, whether it's developers, operation, DevOps folks, could go and give as much value to the company as possible, and ultimately translating to close to 10% of the total IT budget within the observability space being used. This in turn ultimately leads to a decision that needs to be taken around what do you cover, how do you cover it, and also experience that in our eyes for sure is fairly difficult for the average user that needs to go and get value out of it, and when they encounter an issue, be able to go and figure out what's happening in real time. And the reason that that's ultimately so important is that the average, MTTR here, mean time to recovery, is 30 minutes within the places that were asked within this survey, and there's at least 2 outages a month of high impact. What this ultimately means is that equates to about $5,600 per minute. So this adds up to substantial costs that, though maybe not direct and kind of paying out of pocket, you end up incurring for your company that could be resolved via better, fuller observability. And why do people ultimately need to go and decide between these two things? That's a little bit about what we're going to talk about today. So kind of moving on to this next question, I would kind of raise it to you, Chazi, a little bit. Could you kind of walk us through a little bit of this trade-off that you've encountered between cost and coverage in the observability world?
Yeah, sure. So how do you know what data to save, right? Like, how do you know what is important and what not? Like, how would you decide if you need to save that log or not?
Yeah, I guess most of the people know that by encountering it in hindsight, right? Kind of saying, I wish
Right.
I had this.
Exactly. So on one hand, you have the SaaS vendors, right? They are making money from every log line that you send. It doesn't matter if the log line is reported or not. And on the other side, you have the customer who's trying to save, to send as less data as possible. So who's right? How do you know who's right? So I think the basic thing is you want to be aligned with the customer. You want to be, you don't want to use money as a penalty for not sending the data. So I'm gonna take it back to you. Let's say you saw this incident, you saw this log line, and you don't need it. What do you do now?
I guess I get rid of it moving forward, right? I ultimately kind of go and clean it up for the future in order to get rid of future incurred penalties that I may have.
And then a week goes, and then you need this log line, and then you kind of edit again. And so actually, it's unsolvable. That's why we in groundcover, we build a new architecture that we don't make money from the volume you send. That makes us align with you and make sure we are on the same page with you, that you're going to save only the data that you actually need. So we are on the same page, and that makes us, it gives us more tools to choose what data to save and for how long. And I think that's the basic of how you start solving that problem. You want to create alignment between the vendor and the customer that actually need the data. So they both have the same agenda, and they both have the same goal, which is getting the right data and not anything else, because no one is enjoying by sending garbage data and storing forever, right?
So why doesn't everyone have this approach? Why could you at groundcover, we at groundcover, go and kind of look at this with a different philosophy?
So I think the fundamental thing is that we believe that you don't need to send data to someone else. So if you're a generic vendor, we don't need to mention names. We all know them. So you kind of store all the data at your side. So once you do that, you have to make this mechanism of some kind of measures how to reduce the volume data that customer actually send you. We at groundcover, we took a whole new approach. So all the backend is stored in your environment. That makes us very neutral regarding the volume of data that you actually save. I think it's very unique. I don't know anyone else that does that in a scalable way. That give us the privilege to be on your side and help you decide what data you actually need, which other vendors need to store then that costs them money.
Yeah, I mean, there's ultimately kind of a conflict of interest in this space. I mean, obviously in observability, but in consumption-based models in general, short-term shareholder profits always will come at your customer going and storing more, using more, but the customer's experience, giving them the best benefit to them, will ultimately come through them being able to go and get the most out of it and using it the most and finding what it is they need in the time when it actually matters. So I would maybe equate it to kind of I don't know, big energy talking about kind of alternative energy sources and wanting to say that they're doing something in the matter, but ultimately having this immense conflict of interest. And I think here it could only really be a disruptor or a newcomer that could really go and fill that void.
I totally agree. I think it's a very good analogy, and I think there's something. It have to be something new fundamentally in terms of technology. It couldn't be just a business decision. It have to be the whole new architecture and software design that will emphasize on locality of data, stream processing, and dynamic processing that to allow this kind of new era of observability.
Absolutely. So you touched on kind of stream processing, and you touched on like how could we go and make sure that we see absolutely everything. Maybe you could kind of bring us a little bit deeper into the tech around that. Explain to us a little bit of what is eBPF and how does this work into our secret sauce that we're building here at groundcover, and how does the sampling work, everything else. How could we make sure that you have the right information at the point in time when you need it?
Well, that's a very good question, and I think it's the fundamental question that we started groundcover. That's what we asked ourselves. How do we solve that? And I think the basic, if you think about it, is a pyramid, right, of needs, if you want. So the base will be that you want the data, you want to know everything, right? So who's talking to who, and what is doing what and where, and for that you have the old school approach, which means instrument your application. So go over all your application, import your SDKs. It never works on first shot. Probably have some crashes in production, so on, and that's fine. That's how people used to do that. eBPF is a technology that allow you reprogram the kernel in a very safe and efficient way. So it kind of give you like superpower in terms of you can think about it as an MRI or X-ray or whatever, in terms of you can see anything and slice and dice it. So the first layer is done, right? We have all this data, we can now see everything, but that only make the problem even worse, right? Now you have so much data, you don't know what to do with that. And I think that's where groundcover and stream processing in general as an approach comes to hand to basically allow you to process that data efficiently without exiting the node, and which that's the expensive part. Serializing the data, transferring to another place, deserializing and all that, that's really expensive. So what we do is we ingest all the data at the node level, create baselines, create metrics, and on top of that, we can now detect what do we want to save, what looks suspicious, what outliers do we want to save. And I think that's the secret sauce, because we have customers running 10 million API per second, and from there you probably care about 100. Most of them are more of the same. It's repeated Redis commands, HTTP commands, and so with stream processing you can actually find a needle in a haystack.
So you essentially are able to take all of that data that you're seeing through our sensor that's running on top of the kernel in real time, translating that ultimately to metrics. But then you're also able to reduce the client storage cost by going in and kind of flagging the things that will really matter to that user when there's an issue. How do you feel comfortable doing that? Could you dig into that a little bit? What kind of algorithms we have? How do we go and think about the way that we make sure that everyone will have the data that they need in their time of need?
Yeah, sure. So we're basically, if you think about how you will troubleshoot an issue, right? So first of all, you probably try to understand what endpoints do we have in your system, right? So you create these entities around actual endpoints. So endpoint could be a URL, a specific URL, a specific resource, a specific SQL query. So that's the foundation of understanding the distribution of data. You split it to different entities, and on top of that, you kind of learn the simple, old school baseline. So what do you care as a developer? You want to know throughput. You want to know error rate. You want to know latency. So once you get those baselines, when you think about it, so think about the 10 million HTTP requests per second. You can convert those traces to maybe 6 numbers and report them once every 30 seconds or maybe 15 seconds if you really care about resolution. So once you create those baselines and you can compare each and every span that you have to those baselines, you can actually have this notion of, oh, this is unique. This is pretty high latency. Oh, this is unique. This is a very small request. So it's kind of, basic question that every engineer would ask himself. We're doing that dynamically and create this collage of data around these endpoints. So when you troubleshoot and you investigate, you kind of feel like you have all the data out there. You don't even understand you have some kind of sampling mechanism.
And I know that's what kind of impressed me about GroundCover the most when I originally got here. It's that a lot of our customers don't even understand the mechanism behind how we decide what to show and when to show. They just know that they have all of their data always, and they're able to go and to get that at a fraction of the cost that you would via a traditional observability solution. So we spoke a little bit kind of about the architecture. We spoke about the fact that essentially this is deployed on the customer side, which reduces a lot of this cost associated with moving the data. And you put eBPF on top of that, the ability to go to listen to all of these different kind of requests and all of this traffic that's going through the system, and to be able to see it in a native way without any instrumentation. But I think one of the things that gets a lot of people excited as well is kind of this side effect that you get around privacy. Could you explain that a little bit and kind of touch around how this came to be? And was this something that you planned for, or is this just kind of the fact that you're trying to deal with cost and volume in such a way that there is no other solution?
So that's an interesting thing that I honestly did not plan that. When we started, we just thought about how we make it scalable. So how can we, us as I'm talking way back, right? So after 3 months, we already deployed the system on a big company in production, and we want to make sure it's going to work, and we want to make sure everything is going to be stable. So then we started to think about this idea, and the feedback that we got was amazing. The head of DevOps said, "Oh my God, so the data is never leaving the cluster, right?" And we just understood, like at that moment, we realized this is completely new. Like this fact that the data stored in their cluster and only fetched to the UI when they actually browsing the data. So if you can think about GroundCover platform as a tunnel. So when a user log in, it uses its credentials, the same credentials that you use for generating the API key. So you kind of have this encrypted link between the browser and the backend, and we only wiring it. So data is never stored in GroundCover at all, and that gives you as customer the freedom of saving everything, really everything, because all of us are now aware of GDPR and privacy and different aspects of logging and obfuscation. So the fact that the data stored in your cluster, in your storage with your policies makes a huge difference. So, we didn't plan that, but after 2 or 3 feedbacks from customers, we kind of said, okay, this is something, this is big. And it allows us to get into financial services, insurance services, ad tech services. I get it now, especially when I'm on the other side. It's really important for me to understand all the data I have stored in my S3 buckets or EBS.
Absolutely. And kind of while you were speaking there, I pulled up a very, very high level architecture diagram that we have here. Do you mind kind of walking us through the components that we have within our system a little bit?
Yeah, sure. So on each node, we have the daemon set deployed. You can see the little B sign representing the eBPF sensor. And those sensors generating a lot of data, ingest them, and create 2 major things. One is metrics that we store in Victoria Metrics. We're using Prometheus protocol for that. So you can think of this database as a general purpose time series database. You can also ingest metrics from every other source you have in mind. And the other type of data is the OTel information. So we in Groundcover, we really believe in OTel. We kind of adopted the protocol. So we are generating traces, logs, and events using the OTel format and saving it to ClickHouse, which is another amazing technology. I don't know if anyone here experienced ClickHouse, but this is really something out of this world, almost like eBPF. So generally speaking, you have the sensor side, which is stateless, and you have the database side, which is the state and the data. And the SaaS connector is the tunnel that I talked to you before. That's what lets the user fetch the data on demand and just transfer it to the browser.
Absolutely. Now, could you walk us through a little bit of how deployment actually looks? If one of the people on the line now wanted to go and install groundcover, what would be involved?
I'm sure everyone here already installed groundcover because it takes less than 5 minutes, right? So being serious, it's you have two options. One is to use the groundcover CLI, which basically helps you with fingerprinting the cluster and create the last mile tuning for the resources. So if it's reasonable to think that if you have a 300 nodes cluster, you need different resources than if you have like 4 nodes cluster. Let's say if it's a dev environment or some kind of lab, it's probably different from production. So the CLI will do that for you. If you question the cluster, will interact with you a little bit to add annotations, the toleration, and so on. So that's the easy way, right? That's the fast way. But us developers, we always want to configure and understand how things work. So other way is to go the Helm way, and you can use Helm. And you can and with the Helm you can go to the groundcover docs and configure basically everything you have in mind, like specific protocols and retention and basically everything. So those are the two options: very cloud native, very Kubernetes, obviously. Yeah. So less than 5 minutes. If you haven't done that yet, go ahead now and do it.
Go do it. Actually, Chazi is holding out on us a little bit because those are the two standard option. But obviously, for our enterprise customers, we do have additional kind of engagement models that we work with. Do you want to talk to us a little bit about how InCloud looks and what's the rationale that drove us this route?
Yeah, sure. So InCloud is really exciting because it's kind of new. It's on general availability, I guess a month ago. Maybe 2 months ago. So basically what we experienced is customers really love groundcover, and then we started getting those requests of, I want to monitor 10 different clusters and the same backend. And also with that came, the fact that customers did not want to manage the backend themselves, like to the life cycle of the disk, the storage. And with groundcover, we believe in frictionless observability, as you all know. That's the motto of the company. And we asked ourselves, how can we make it more autonomous, more frictionless for customers? And we decided to take the cloud native approach and the Kubernetes approach a step further. So you can think of the InCloud. Maybe you can bring back the slide, which will be easier with the.
Absolutely.
So you can think about InCloud as taking the state, all the state components, so the database and all the metrics ingester and so on, and the SaaS connector, and we provision. It starts with you giving groundcover external role. So you give to groundcover control plane, you give an external role, and from that we have an automation that generate and establish an observability backend. So you can think about that as your monitoring cluster, the dream of the dream you had to establish a monitoring cluster, a dedicated cluster only for monitoring. So groundcover does it for you. So a few minutes later, you have this EKS or GKE or something like that. It depends on your environment, running in your account, ready to get data. And from there, the sensor are a stateless application that only send data to this backend. So you don't need to think about backend, you don't need to think about storage, you don't need to think about backups. Everything is done automatically, and actually it's scaled to infinite. You can send the amount of volume, it doesn't really matter, because we built the entire infrastructure very Kubernetes native, so everything is horizontal and vertical scale.
So the way I like to think about it as well is all the benefits of a full SaaS solution with none of the costs of a full SaaS solution. So you don't need to worry about any of the maintenance around it, but you get this experience that is really, really native. And obviously the core ground cover experience is, well, I'm a little bit biased here, but in my opinion, amazing. And this is kind of an extension for that for companies that really need to achieve it at scale. And obviously for the holier than now that need to go and take privacy to the extreme, the banking institutions, the companies with a lot of privileged PII information. We also offer a full on-prem solution where you could actually get the UI bundled within your cluster as well and get everything all kind of provided to you in a single artifact and allow you to go and have zero communication with the outside world. So kind of 3 really exciting options. And for the majority of the companies, I'd say the kind of 90%, obviously our default deployment is more than enough, and it gives you everything you'll need, and you'll be able to get to scale of hundreds of nodes. But for that kind of extreme 10%, we do have those additional options. Great. So, Chezi, any other thoughts before I jump into a quick demo for our audience?
No, I really like the analogy of having a SaaS experience without paying for SaaS. So I really like that. I'm gonna adopt that.
You could have it. That's what you paid me for. Wonderful. So I'm going to go ahead and show you ground cover over here. I've gone into our demo environment, but it is a 100% real environment where we just have some information flowing through it. And the first place that I've landed on is essentially a table of all of my workloads. And the reason that we go the route of a table is that we believe that everything starts at a high level. You start at the meta, and then you go and narrow down. So it all comes back to our golden signals. It all comes back to having our throughput, our errors, and our P95. And we could go and sort by all of these and understand where we want to put our time. So boom, I click over here, and I see that within my specific workload, I have 100% errors. I could click into it and go and see different types of distribution, different information over here. This is constantly evolving and changing, but we have our pods over here where I could go and see the specific information and get more context. I have additional types of information I'll show you in a moment, but ultimately I could look at a service level and really be able to see everything that's happened over any period of time that I could go and select over here. Now, the next thing I want to go and show is you have additional types of entities here, whether pods or the different types of sets that are ultimately rolled up into workloads, jobs, or cron jobs over here. And you also have a number of other functionalities within ground cover. And one of my favorites is the map over here. And when I look at the map, what I'm seeing is a dynamically created map of the system. So, as developers, as large groups of developers, one of the biggest challenges is documenting the system. And documentation ultimately fails because of its static nature. Here, you're able to really go and see all of your different services, how they interact with each other, the golden signals around each of them. And then if you want to go and dig in, you could use our filters on the left-hand side and look through. For example, I want to see all of the cases where we have some error in communication. And then I could go and click on one of these edges between the two services, and I will actually be able to see the traces associated with each of them, click in and look at the actual request as well as the response of that trace. And this is super powerful because you're able to see the full response using the power of eBPF. We're able to continue to listen and get that response and save it. And that's something that's very, very unique for ground cover. I'm able to see context around my container as well as context around the CPU memory for both the container and node level. And then I could see logs that happened around that trace. So I had a certain error. Now let me go and bring it to a log level to see, did anything interesting happen over there? Now, speaking of interesting happening, what we could go and do as well is look at an issue level, whereby we were able to see all of those traces with the many different errors that are each independent of each other. And we could go and actually understand from the pattern that is written that those are a similar issue that are generating them. And then I could see that instead of 1,000 different unique instances, I have a single issue with 1,000 times where it occurred. And I could click into this, and here as well, I could go and I could both sort and look by latency, filter, but then as well go and see all of the values that were returned over here. That's really cool as well. Another view over here is the traces, where I'm able to go and see not just traces that are associated with a issue or an error, but also generalized traces that we go and save. We're going to go and, when there's no issue, no problem, we'll save the raw data, and we'll do so in a way that will represent the population of data that's flowing through the system according to latency, according to workload. So you have full representation of absolutely everything. After that, you have the API catalog that, again, allows you to go kind of like in a meta approach, top down, will allow you to go and see, where do I want to spend my 2-3 hours that I have here for optimizing. So I could go, error rate, latency, throughput, sort by this again, one way or the other, then click into it and see the corresponding traces that came out of there. We are a centralized system where you're able to go and get all of your observability needs. So we have full log solution with search over here, where you're able to go and to look at the corresponding logs. Again, here we always believe in correlation between events, and that's how you get to a root cause of a problem. So if you click on a specific log, you're able to find the traces around that log. Let's go ahead and look at one with an error. Maybe there'll be something over here. So I can say, okay, this was my error. These are the traces that I had around said error, and I could go and click in here and view it. And another piece that really goes and adds to our data that we have in that the bottom layer of the pyramid that Hezi was speaking about is our Kubernetes events. So if we click into it over here and I go and I extend the time period, I could go and see that I have different types of events that represent things that happen within Kubernetes in order to go and highlight different types of issues and problem. And we're actually working on a view now where we connect between infrastructure, applicative, Kubernetes events, the state of the workload, and different types of artifacts that we create beyond that, and kind of bring that all into one place in a timeline view. So I'm very excited for that. That comes out in the next 2 or 3 weeks or so. In addition to everything over here, you also have a embedded Grafana that we will manage for you, where you have both dashboard functionality, where I could go and click in over here to different types of dashboards, choose my corresponding workload over here that matters to me, be able to see all of the information and data, as well as alerts that I could go and configure. And we're working now as well as at a extremely robust set of alerts that come out of the box that we're calling monitors, that will provide you with both applicative alerts, basically something has happened in your application, a new type of issue, and so on, as well as infrastructure alerts, as well as things in the arena of FinOps, under overutilization, things that are happening in the world of security. And I will say about 80% of our R&D team comes from the world of security, from elite units. So it's something that we want to go and represent over here, and again, be one place where you could get all of this information. So I'm going to go ahead and stop it over there. And if there's any questions, please, I see all of the people on the line here, feel free to shout out. And in addition, if anyone wants to go and to set up time, I'm going to go ahead and drop a Calendly link in a moment, and you guys could go and reach out and set up some time with me as well.
Maybe we'll wait another minute to see.
Yeah, we'll give it one more.
I think every demo you're doing, I'm getting more convinced this is a pretty unique platform. I'm really proud of what we built.
Yeah, absolutely. And it's amazing kind of the development that happens day by day, week by week.
Okay, I guess no more questions. Everything is clear. Everyone is busy installing groundcover, I guess.
Absolutely. Absolutely. Okay, I'm having some challenges here with Calendly. But we have a extremely active Slack support as well. Any questions, please feel free to write it over there and request some time with us, and we'll be sure to set that up. We take a lot of pride in kind of putting our customers first and going and making sure that we're there from a support perspective. So there's no support team, but everyone here is that team. So we're here, write it out, and we'll be sure to get back to you. Great. Thanks so much, everyone, for your time. I know it's, it doesn't go without saying that you'll tune in and spend the 40 minutes listening to me and Chazi talk. And thank you, Chazi. I enjoyed it quite a bit.
Yeah, it's been a pleasure. Thank you for having me.
Cheers, everyone.